Okay, ladies and gentlemen, let's go ahead and get started. Thanks to all of you who came in person, and thanks to everyone watching at home. We had our latest film on Monday, okay? And we're still kind of, if you look at the schedule, we are in this kind of rest period. We don't have a project going on right now, but you do have something to be working on. What should you be working on? What do you got? Yes?
The postmortem.
Yeah, the postmortem. And as a reminder, right, this is not a literature course. This is not an English course. When you do a postmortem in this course, we are asking you to look into the past and to hopefully enjoy doing so. Take a little bit of a break, rest, and just reflect on how the previous few weeks have been. Is there anything that you could do a bit differently on P2? On the other hand, is there anything that went really well, right, that you want to reinforce in future projects? Okay? It's always worth taking some time after a big effort to kind of sit there, chill a little bit, and reflect, okay? That is how you will gain the most XP from all that effort that you put in. So, you've got your P1 postmortem. It's not a super long essay. You just kind of answer the questions. And remember, we don't care about your sentence structure. We don't care about your grammar. Just dump your brain as quickly as you can and be honest with yourself, okay? And you'll be done in no time. Okay, so let's go ahead and get started. We are not going to begin your Project 2 until Monday, okay? On Monday, we're going to begin Project 2, which means you should probably start thinking about that P2 team that you want to form, okay? If you forget how to form a team, go ahead and click on that link right there on the schedule. You can go to the team formation guide, and it will tell you how to create your team. If you do not have a team on Monday, then Monday evening, I will provide you with a team, okay? And you'll have to live with whatever happens, okay? And sometimes that goes really well, sometimes not so much. And I encourage you to try and find some teammates if you can, okay? Look in the exhibition channel in the Discord server, right? Look at what people are making, and if something really resonates with you, send them a DM, okay? That's why the exhibition channel is there. Okay. So, before we really get into it, I have a company, a local company, one that I'm actually pretty close with that I want to show you. SaganWorks, now known as Saganverse, is a startup company, a VR company in downtown Ann Arbor, and they have kind of built their product off of EECS Dubsoft Studio, and EECS 440 Talent, okay? They have received, I believe, at least several million in funding. They have been around for quite a while. They were created by Erica Block, a local entrepreneur, who thought that she had a great way of organizing information in a way that would help you recall it faster. That would be more useful, more impactful, and more productive. So Saganverse, right, they actually used to have a different name. They used to be known as SaganWorks. First question, why would you change your name, the name of your company, from something like SaganWorks to Saganverse? Yeah.
Can I try to find what that is?
Yeah, go ahead. Walk around. Why would you try and change your company's name to something with verse at the end? Why would you do this? What's the point? Yes?
It's like the metaverse.
Yeah, right? So Mr. Zuckerberg changes his company name to Meta. He starts talking with his very big microphone about something called the metaverse, right? It is kind of an aspirational concept. And if investors are really excited about the metaverse, then changing your name to include it is useful. In the before the kind of 1999 tech bubble burst, there were a lot of companies that would just put .com into their company name. And they would do this basically just to cash in on the hype, okay? If you had .com in your name, your stock, your company's value, interest in your company would go through the roof despite you not really changing anything about your company, okay? And so I guess the big takeaway here is that companies and business and financing is also a bit of a popularity contest, okay? It is not immune from trends and hype waves and all of that stuff. We're going to talk about how technology intersects with the hype cycle and how that can, unfortunately, be used to cause abuse, to enable abuse. We're going to talk about that toward the end of the semester, okay? Tech and hype, a potent combination. But this is Saganverse, right? And this is a company that basically allows you to create these virtual digital spaces aimed around organizing information, okay? In reality, it seems to be most useful for things like virtual exhibits, okay? Virtual museums. It's a tool that allows you to very easily create a space that, students or field trip people or whatever can go in and enjoy, okay? You can see the tools here, right? So you can very easily drag images right in and place them on the walls. You can very easily adjust the layout of the space. You can bring in a preset collection of objects and models. And you can also upload your own stuff, okay? So you have spent 3 weeks, right, using your 3 or 4 years of computer science education building an Unreal Engine environment. But what if a marketer had to do the same? They don't know Unreal Engine. They don't know how to program, so they can't really use blueprints. How do they create an immersive, interactive environment on the cheap and quickly? Well, usually you build a tool that starts limiting your options. And by limiting your options, you can kind of enforce a certain floor of quality, okay? So that's kind of what we have here. We have Saganworks. Saganverse. It is an online tool that allows you to create digital environments very quickly and easily and fairly expressively, but without having to be an engineer, okay? Let's go ahead and watch this video. Maybe it'll give us a better feel for what the company is these days. Actually, this isn't a video. This is actually loading up the experience itself. So if I recall, this is actually a tool that is made in Unity, and they use the web build functionality of Unity in order to create, interesting environments here. Okay, so we're now in a museum. We didn't need to install anything, okay? And I can click on any of these paintings. It kind of gives me a really nice view of it. Does it have a... Oh. Is it going to play something? Oh, error. Okay, guess not. RIP, and the whole thing is crashed. Okay. Well, that's how it goes sometimes, right? That is the startup experience. Anyway, right? So if you need a virtual environment, some sort of digital experience, and you need it quickly, and you don't have engineering talent to build it in a game engine, then you can still make it work using a tool like this, okay? Walk around, get more information. So pretty cool stuff. And I think, actually, this is a real deal museum. I think this is a museum in New York. I've forgotten what it is called. But will they tell us? Oh, you've got other experiences, right? So safety training, right? So you're in a warehouse. I think they've got little interactives. Oh, find them all. So there are, it is possible to build some interactivity into these environments in a way that makes them work. Let's see. Click that. Looks like it's still loading down here. So most of as far as I understand it, most of what has been built was built using student talent, a lot of it. And I know a few of the students, at least, who built it in the early days. So you can find 18 hazards. Okay, so what kind of hazards are we looking at, right? This doesn't look good, just kind of dropped around here. Whoa. Okay. Oh, there's a person over here. Can we talk to them? Oh, it's just a 3D model. Okay. Anyway, right? So pretty cool stuff. And they provide some ideas, right? You can have training in here. You can have learning areas. You can have portfolios. So if you want to have kind of an interactable, walkable portfolio, then you can do that. It looks like this one is actually for someone who might have passed away. And it's kind of an interesting way to maybe remember them and what they contributed. So we are an easy-to-distribute 3D immersive platform that enables users to consolidate media into hubs, create and maintain virtual exhibits to engage them in new stories, educate them, and build portfolios. Okay, so if you need a digital space, they can help you build it very quickly. So I'm curious, the appeal seems pretty clear, but I'm curious what kind of pricing they have going on. This seems to change every year or so. Let's see. So what comes with a pro subscription? You get a growing room of kind of default templates and 3D objects. So all these things, you can just get them and you can just use them. Guided tours, so you unlock the ability to kind of quickly bring people around to see the highlights, so they don't have to manually walk through. That could be kind of useful. You gain notes, labels, and editable documents, so you can actually put things on the walls and stuff. I guess you can't do that in the free version. Room portals, so you can jump between rooms if you need to. Colorization. Yeah, it seems like maybe some of these features have been taken out of the free version and put into the pro version. I will say, unlimited space. Okay, unlimited rooms you can choose. Unlimited items within rooms. At some point, it's going to start lagging, so there has to be some sort of practical limit. And increased cloud storage, so up to 20 gigabytes. Okay, so pretty cool. One very interesting thing is that this company has been around for quite a while, but I don't think they're revenue positive yet, or even revenue neutral. And so one thing that you'll often see is that a company comes out with a really cool new product, like a game engine, right? And they won't really charge for anything. You ask, hey, how are you making your money? How are you making revenue, keeping the lights on? What is usually the answer? You've got a new company, cool new product, but you're not really charging for anything. What is the answer here? How does the company keep their lights on? Investment, right? Basically, they're spending investor money on your behalf, okay? And they are allowed to keep raising more money, keep burning cash so long as their numbers continue to improve. They're gaining more users, they're gaining market share, but at some point, they have to flip the switch and they have to start heading toward revenue neutral, okay? People invest in a company usually because they want some sort of return, and so eventually the team has to find a way to make money. And as a company gets older, it tends to put the squeeze on. Does anyone know what Unity did? I think it was like a year ago. Very dramatic and controversial. Unity changed their policies kind of out of the blue to say, hey, pretty soon we're going to start charging you money per install of your game. Okay? Now that's really scary because what if you release a free game? What if your competitors install your game a bunch of times just to run you out of cash? It's really spooky. So they got in trouble for that. But the reason that happened is because Unity is not profitable. The engine company is not profitable. They're a bit too big. They haven't figured out how to make cash. Unreal Engine, or at least Epic Games, is profitable. Unity is not. And so they have to start putting the squeeze on. Okay, so in general, be careful about companies that are giving you a lot of great stuff for free. That's wonderful. But if they're not revenue positive yet, then that is eventually the music's going to stop. Okay? So a really cool company. They've got a really cool product. Hopefully they can find a way to make money here. Fairly novel. But when you ask yourself, what kind of social impact does this allow? Well, By itself, not much, right? The question is, what will people do with this tool? And if someone does do something amazing with the tool, who gets credit for that? The team that used the tool or the team that made the tool? It's interesting to think about, okay? All right, so pretty cool company. Let's see here. Some announcements. Roblox has their main recruiting event with Michigan hackers this evening, okay? I believe it's 6:30 in GG Brown, so right across the way. It's right next to Dow, kind of in the corner between Dow and the EECS building. And this is I just had lunch with the lead recruiter, David, yeah, like Roblox is very, very high on U of M students. They have taken a lot of our students from these courses. So if you're in need of an internship or a junior offer, then your chances with them might be a little bit better than with just a typical company, okay? So I encourage you to go and check them out and apply if you want to. Roblox is a really cool platform. They have a ton of users. David said they have 70 million users, like monthly active users. And a large portion of those users are younger users who are learning to program, right? Learning to create basic 3D models and create their own little communities. Yeah, it's pretty cool stuff. So anyway, definitely check them out if you can. And if you don't want to check them out, IGDA Ann Arbor is happening tonight at the same time, okay? I didn't plan it that way. That's just how it happened. But you can get, I think, a tiny amount of extra credit for attending events with IGDA Ann Arbor. Tonight, Michigan's largest game studio, Stardock, they're in Plymouth, about 20-minute drive away, is going to be talking about the topic of production and project management. How do you properly allocate resources during a big game production? And how do you keep those projects famously difficult to keep on track? How do you try and do that? Okay. The creative process, as you'll learn if you take 494, the creative process is a fraught one. It doesn't matter if you're writing a novel, making a new film, drawing a painting or an image, or creating a game or a VR, AR app, right? The creative process, you just don't always know what's going to work. You don't always know which direction to go. And so you have to adopt this really iterative process where sometimes you have a great week and then sometimes you take a step or two backward. Anyway, Jerry's going to be talking about all of this stuff tonight, and there will be free food and stuff like that. So if you're interested, downtown Ann Arbor at 6 p.m., that's where I'm headed after office hours are finished. And Ravi's going to be showing off some cool stuff, graphic stuff there tonight, as well as Jacob as well, going to be showing off an engine, and should be a good time. Okay, Dr. Missel is seeking some talent in the University of Michigan Medical School, seeking VR and AR talent. And this is, I don't know how old this is, but because I just get a lot of this stuff. The Center for Academic Innovation is also seeking talent, Eric Schreffler. And this is all to say that please do not forget about that jobs and internships button at the top of the Canvas page. And don't forget about those academic opportunities, all right? If any of you want to go to grad school, you can get a letter from me if you do a good job in this course, which you all will. But if you go and do some work and help out a research lab on campus, that is a great way to get a second letter. And for most applications, you only need about 2 or 3, okay? So boom, there's your grad school right there. If you don't have an internship and you're looking for one, then this is a really good substitute. Working with a research team, a lab over the summer can be really, really positive and useful, okay? Anyway, don't forget about this stuff. Lots of helpful advice and tips and places to look, okay? And if you ever have any questions, you can ask me about those. Make use of these opportunities while you have the chance, because there's a very big difference between a undergrad student asking and cold calling these professors and some random person, right, in their 30s in the community, okay? That's a little bit harder. A lot of things become harder when you're no longer a student, okay? All right. So you're working on your P1 postmortem. Good. I read a few of yours last night. Looking great. Project 1 is finished. This is the first chance we've really had to talk about it, okay? And I want to get your thoughts. This is still a very young course. It's a fairly new course, and it's going to be changing a good bit over the semesters. And I'm curious, how'd it go? Was it useful? Was it challenging? What parts of it were challenging? How was it? What do you got?
I thought it was pretty useful and fun. A bit of the logic and scripting things like versus stuff was a little bit tricky for us to figure out.
Oh yeah, which ones? What was the toughest? Whiteboard is very typical.
Whiteboard was hard. I had some problems with the day-night cycle.
Yeah.
Oddly enough, and
Okay.
it was just a random thing. Like some of my game engine files got deleted.
Oh.
I don't know why, so I had to re-download them.
Okay.
That's where like the app or the Sky thing was. That took me a long time.
Got you. Okay.
On 2 different occasions, I somehow accidentally deleted the static mesh for like the default cube.
Oh.
And had to like
Yeah.
do the Epic Games launcher, like try and relaunch the whole project so it
Yeah.
fix it automatically.
Yeah. So some of the things within your Unreal project are actually shared among all projects on that computer. So sometimes what can happen is if someone goes in and deletes the object, they accidentally delete it from the entire computer, which means it'll disappear in projects that you weren't editing. And I think Unreal does this just to make sure that your projects stay smaller and they don't eat up your entire hard drive. But there are some consequences to that approach, right? And sometimes they bite you. Okay. Any other thoughts? Yeah.
I feel like especially towards the end of the project, like the file organization really started to become an issue.
Yeah.
Like, we're kind of just randomly dragging the like custom assets in, and suddenly there's like a million folders.
Yep.
Like, numbers and random buttons.
Yeah. Yeah. Your first few models, it's no big deal. You just drag them in anywhere and hey, it's not a big deal, but that doesn't scale super well. And you might not realize that until you've already gotten in too deep. You've got too many models, they're a mess, and it's hard to find anything. That's why, right, you want to get used to kind of using that search bar to find things. And if possible, you want to try and keep your hierarchy of folders somewhat sensible, okay? But it takes some discipline and it takes some time, okay? And time is not something you always have. If you've got a deadline tomorrow morning and you are already at 3 a.m., you can barely keep your eyes open, sometimes you just have to do what it takes and knock that thing out, even if your project gets a bit messier. Hopefully, though, you return to the project later, you can fix it up, clean it up before that stuff starts to really pile up, okay? So anyway, that's something that hopefully you'll get a chance to correct on P2. P2, your P2 project's going to be pretty messy, okay? And by default, because you're going to be importing Mapbox, right? You're going to be using some tech that you might not be familiar with, all right? Actually, we were talking about that this morning in 494 office hours. One of the best abilities you can have as a programmer is the ability to look at an existing big project, be it an open source project or be it the Sims 4, multi-million line source code. And you got to be able to dive into all that source code and kind of work your way through it and figure out where is the important stuff, okay? For the task I currently have, where do I need to be? I remember when I hopped onto the Sims 4, it was toward the end of development. It had already been going for about 4 years at that point, and it was coming out. And you want to get in there and sort your way through millions of lines. That's tough, but you can develop techniques for it. And on P2, that's what we're going to do. Okay, on P2, we're going to import some cool technologies, and then we're going to dive in and kind of dissect it, and we'll hack in and just find the place we care about and get our job done that way. Okay? All right. So I hope Project 1 was at least useful to you. We're continuing to edit it, and if you have any thoughts or feedback, please fill out the form for P1 Gold, P1 Alpha, P1 Milestone. We use your ideas and your feedback between each semester to kind of fix things up. Okay, so Before we conclude P1 and leave it in the dust, I want to show you just a small handful of some of my favorite projects that I saw coming out from you. And this was, there were a ton of cool projects. I haven't seen them all, but I've seen a few, and we had some very creative ones. So we got more of them coming. This one, a very, very good-looking project. This one by Devin Chin and William Chen. Are you in here? No? Okay. A lot of people watch from home. This is, I don't entirely understand quite yet, but our Beister laboratory has had, I think, a nuclear button or a nuclear launch button put inside of it. So let's see here. So the goal here is to find the buttons. Yep. To deactivate our launch here. Oh. Wow. Hidden in every corner. And I guess I don't understand exactly what happens when it turns off. Maybe it's just a mini game. Maybe it's not a launch. Anyway, we hit all the buttons, and then... Ah, there it is. Secret wall explodes, and there's a rocket launcher, dual rocket launchers in the CSE building. Who knew? And they are functional, so you can, let's see here. Okay, so I think you can actually, let's see here. Right? So they look fantastic. They've got great particle effects. They sound great. And they interact with a lot of the physics objects in the environment as well. So pretty cool stuff. If you're frustrated after a long night at the laboratory, the autograder is not giving you 100%, those rocket launchers are there for you to, I guess, work out those emotions. Okay? Next up, we have Jason Zhang and Morad Yassin. Are you in here? Yeah, all right. We have CSE surveillance. I saw just a little bit of this one. In this version of the CSE building, you are under watch at all times. It feels very oppressive. And these cameras are looking back and forth. And they have their own line traces going on. And when they see you, I'll be honest, I don't remember exactly what happens. So what happens when they see you? Oh, how do you cheat in here?
So we have ChatGPT, which is just basically another NPC or
Oh,
all.
ah,
I think it's halfway.
yeah. Oh, got you. Okay, yeah. Let's. So yeah, if you use ah, so if you're talking with your friends, if you're cheating, if you're, yep. Oh, you got caught. You get seen by the cameras. You get sent to the honor council. So there's a phone. Oh, guilty. Nice. So we've got a new environment here, and Do you get to learn if you're guilty or not?
No, we think that
Okay. Oh, so you have to sneak out. Oh, wow. Amazing. Very cool. Very cool. Awesome. Well done. I know that, so it's said that these can be a bit of a time capsule, right? So when people look back at this, what was it like being a CSE student for you? I know that there's a bit of tension, right? A lot of students are worried about like, hey, if I write code, but my code just happens to be similar to someone else's approach, like, is that going to get me honor counseled? What if there's a false positive, right? If I did accidentally take some code for someone and I got the honor council notification, right? That's really scary stuff, okay? And it weighs on a lot of people's mind. So it's really cool that you captured some of that in this project. Last one I'll show you, Isabel Turok and Daniel Tien. Are you in here? Awesome. This was, and I decided to name it Existential Crisis Simulator. The custom feature here is pretty wild and it's a bit spooky. Listen to that ambiance. Got the creaking door, the spooky ambiance, got the whiteboard. Am I real? Uh-oh. So question, is this infinite? Wow, that's amazing. How are you implementing that effect?
I believe that was Daniel. That's what he did.
Okay.
He's just spawning a new room.
Got you.
So we have as the door opens, he just.
Got you. Very good. Very good. Super cool. Very creepy. And depending on how you do it, that can be a pretty difficult task. I imagine the entire room is a blueprint, which would allow you to spawn in a new blueprint, position it just so that it lines up and feels like that. Anyway, super cool effect, super creepy. I love the spookiness, and super impressive projects, everyone. These are fantastic. When you talk about these projects, right, think about how you want to do so. The postmortem assignment you're working on will ask you exactly that question. How are you going to talk about these P1 projects you've done when you're talking to a recruiter or when you're talking to friends or family? My recommendation, okay, this is not an art course, and a lot of these look really good, but that wasn't really the focus. Talk about the interactivity, right? There are lots of really cool environments out there and VR apps and VR games, but you have very interactive ones where you can actually go turn off the lights. You can pull the fire alarm, right? You can talk to characters. You could draw on a whiteboard. Okay, that makes your environments special. Okay, you'll find a lot of students out there have cool environments. In many cases, they've kind of downloaded them from the internet, but they haven't gone in and created this affordance system that makes it so nice and easy to add in interactable elements into the environment. So I encourage you to talk about that part, okay? Also, your project management, your teamwork, how you dealt with that is really good stuff, okay? So what I want to do today, we are still in that resting period, right? Hopefully you're chilling, you're working on some other courses, you're getting ready for P2 to begin on Monday. But as P2 is beginning, we got some stuff we're going to have to deal with, okay? You, in this course, have to deal with 2 different game engines, and not many courses require you to do that, okay? So we need to take what you know of Unreal Engine. We need to take those patterns, right? How do you do things? How do you write code? And then take that code and put it on an actor or on a component that then goes on the actor, right? How do we take all of that stuff and translate it to Unity? The good news is that Unity and Unreal are very similar engines once you realize it, once you've had some time with them. But it might take some time to get used to the UI, to get used to textual programming instead of the blueprint visual programming you've been doing. And so today what I want to do is I want to take you through, and we're going to build some Unity stuff together, okay? Have some fun. I'm going to explain Unity's philosophy and show you how to do some basic stuff. Your mission as you watch this, you don't have to take notes. You don't have to remember all of this. Your mission is to try and think and translate what you know from Unreal to what I'm going to show you in Unity, okay? Crossing that gap is going to be your hardest challenge here. So this is what Unreal looks like. This is what you're used to. If you haven't messed with the UI at all, it actually looks a little bit more like, let me see here, like this, okay? That's mostly what it looks like. However, I'm going to bring this over here, the outliner, this is what you see, right? You've got lots of actors here, and you can click around, and you can mess with them. You can move them around, gizmos and stuff. When you click on an actor in the details pane, you'll get to see the components, right? This cube has one component, right? This wall has one component. This little pistol here has 3 components, okay? Boom, boom, boom. Now, when we switch over to Unity, we'll see much of the same stuff, but in a much more simple format, okay? In general, Unity is a more simple, right? A little bit more beginner-friendly engine, okay? Its architecture is more simple and a bit more consistent as well, okay? There are fewer features in Unity, which for many people makes it a bit easier to learn. When you get to Unity, you've got this world, this big viewport, just like you do in Unreal. And you've also got your outliner, except it's usually on the left instead of being on the right at the top here, okay? But we can drag our UI around, and you can get a good feel for what it is like that. When you click on these game objects, you'll see them highlighted in the viewport, and you'll also get to see all of their components on the right-hand side of your window, right, in the inspector. Now, the UI is a bit different here, okay? Riddle me this. How many components does this game object have? Right? It's a bit far away, maybe. But remember, you can watch on Twitch if you want that close-up view on your screen. How many components do we have on this particular camera, main camera, game object? In Unity, it's called game object, right? In Unreal, it's actor, but they're the same thing. How many components? 3. Bingo. That's right. And if you look at each component as kind of its own section, we can actually close each section, and it's really obvious. We have 3 components, okay? Now, we can open them up and see all the nice details within them. In Unreal Engine, almost every game object is going to have that static mesh component. And the static mesh component has the position data, the rotation data, the scale data. It has mesh data. It has physics data. It has all sorts of stuff, okay? It's just jam-packed. In Unity, Unity doesn't like to do that, okay? Unity likes to split all that stuff out into smaller components that are a bit more focused. So, right, Unreal has static mesh component, which has the transform data. In Unity, that transform data is literally in its own small component, okay? It has position data, rotation data, scale data. And if we have physics, well, if we want physics, then we'll add that as a different component, okay? So let's look at the scene here. We've got 2 objects. Neither of them are very interesting. Just like Unreal, we've got that little play button toward the top, right? So in Unreal, it is kind of right down here a little bit, but in Unity, it is front and center. So when we click this in Unity, what are we going to see? Ugh. Hopefully. There we are. So when we run our game in Unity, right, it's probably going to blow up into this big view of the game, and we can see nothing. The reason it's taking over our entire screen here is actually because in the game view, we've set it to play maximized. If we switch it to play focused, then we can run the game without it getting all super big, okay? So while we are playing the game, you can actually manipulate your objects. So you can click on the main camera, for instance, and let's rotate the camera, right? I'm doing that right now. While the game is running, I'm messing with the camera to just experiment. When the game stops running, I lose those changes, okay? So that's kind of a cool feature of Unity. It's a little bit easier in Unity to pause the game while it's running and then inspect it, view things, and experiment that way. So when we want to add a new actor to our map in Unreal Engine, we got that little big plus button, right? We can go in, we can get basic shapes or whatever we want. Shapes, get a cube, okay? Just drag that right in. In Unity, it is kind of similar, okay? If you go to your hierarchy view, which is what Unity calls the outliner, you'll see this little plus button. You click plus, you'll find things like empty object, okay? Create empty, right? When we create empty, we'll get a single game object called game object, and the only component that it will have is the transform component, okay? We can see here's the game object. It's in our scene. It has a position, rotation, and scale, but it's invisible. It doesn't really have anything to show, okay? So we actually want to add in not an empty game object, but a 3D one. So let's grab the cube. Now, this one is pretty simpler. It's pretty similar to the empty object, but it has a mesh render and it has a box collider, okay? So in Unity, much like in Unreal, if you want to know what an object does, or an actor or a game object does, you can simply click on it and you look at its components. If it doesn't have any interesting components, it's not going to do anything, okay? So we look at our cube here. Let's say that we want this to become ground, okay? I can move it around with these gizmos, or I can zero out the transform just like this, and we're going to put it at the center of our world. One really useful thing, it'll make your game engine life much cooler, much nicer, is to learn some basic hotkeys. So in Unreal and in Unity, if you click on an object, by default, you get the ability to move it like this, translation. But if you press E, right, your fingers are on WASTA. If you press E, you'll get rotation mode. If you press, R, you will get scale mode. So you can just very quickly manipulate your objects. And if you want to become an expert with engines, you can just, you want to learn these hotkeys. So you can quickly move things around. Okay, and switch between rotations, right, getting those good, scaling, all that stuff. If you want these gizmos to be local to the object instead of global, you'll hit X, right? And you can now see that we've gone to a local approach to our gizmos, right? You can press X to go back to global, right? In Unity, as in Unreal, you might ask yourself, well, which direction is the x-axis? Which one is z-axis? Which one is y? Okay? And you can look in the gizmo in the corner to get a feel for that. Okay? Unity, in my opinion, has a really good approach. It reminds me of graph paper, right? You got a piece of graph paper, x to the right, y upward, and Unity adds z dimension, right? Because it's a 3D engine, and that is z, it's into the screen, okay? Unreal actually has a different one, okay? So in Unreal Engine, you can see the gizmo in the bottom, right? Z is actually up, okay? And then X is to the right and Y is down. So that's kind of weird, okay? Y is actually toward you out of the camera. So you might have to get a little bit used to the differing axes. But anyway, let's take this cube. I want it to represent ground. So I'm going to change its name to ground. And it's already at 0, 0, 0. I'm going to zero out its rotation. So it gives us a nice flat surface. I'm going to make it a little bit flatter. I'm going to make it a little bit longer, okay, and wider. I'm going to look at where my camera is. There it is. And when you click on the camera, we get this nice preview view in the corner that shows us what it's going to look like. We can also get this by going to the game view, okay? I'm going to bring the camera over here. I'm going to raise it a little bit and then tilt it downward. So we've got this really nice view of the ground, okay, like this. Okay? So we have our ground here. Now, I want some sort of player character, okay, or some sort of interactable object, game object. Again, you don't have to be keeping up with any of this, right? Just enjoy and try and make connections between what you know in Unreal to what I'm showing you in Unity. Let's go to that big plus button, right? It's the same way in Unreal, right? These engines really are all the same. Go to 3D Object, go to Sphere. Engine developers will probably get frustrated with me if I say that. All engines are pretty much the same. Let's see here. Okay, I'm going to bring it over here. I'm going to turn lighting on, the little lighting button in the corner. Here we go. This is going to be our player. All right, we have this sphere. I'm going to call it player game object. And when I launch the game, I expect it to fall to the ground, and then I want to control that sphere. I want to roll it around. Okay, so let's take a look. I'm going to go ahead and play the game. We'll maximize it. And here we go. Okay, what happened? This isn't what I wanted. It's just stuck there, okay? Now I can move the sphere around while we play the game if I pause it and then move the sphere, right? Change its data, but I want it to fall. So what can we do to make it fall? Well, remember, in game engines, right, an actor or a game object will only do things if it has an interesting component on it that will make it do that thing, okay? So if you ever wonder how something works, you click on that object, you click on that game actor or game object or actor, and look at its components, okay? What do we got here? Well, like all game objects in Unity, we have a transform, okay? Position, rotation, scale, all good. We have a mesh renderer, and we can actually turn it off and turn it back on via this checkbox, and you can get a feel for what that does right away. The mesh renderer component will render your mesh, okay? Without it, we're invisible. The sphere collider here would allow us to collide with things if we could get to them, but we don't have any gravity. We don't have any velocity. We don't have the ability to fall. So we need an additional component, right? We don't have enough components to accomplish what we want. If you go to add component on the bottom here, right, this is kind of equivalent to going up to that add plus button right here, okay, add a component. I want to add a component, and Unity provides you with a lot of really great built-in components. One of the most important ones is in the physics category, so we click on physics, then we go to rigid body, okay? Rigid body, once you open it up, has a ton of different tweakable, configurable variables in there, right? You can see that it has a mass variable. It has a drag variable, angular drag, use gravity, so we can turn off gravity if we want to. But when we run the game now, we're going to see this ball fall, right? Boom, just like that, right? We've given our game object a new component, and thus our game object has gained new functionality, okay? That game object, that component can be tweaked in many different ways to change how it works. And we can start playing around, right? We can go ahead and tilt this if we want to, tilt our ground, and now expect the ball to go ahead and fall off and roll off. And there it goes, okay? We have physics working in our game now. One question, though, is what if we want to control this ball? What if we want it to be able to move around? When I press the arrow keys, I want this ball to roll in that direction. So what do we do? What should we do? If you want an actor or a game object to do something new, you need to add a component, okay? But which one should we add? There are all these built-in components that Unity has made for us, but you will not find a single one relating to control, okay? That just doesn't exist. So what can we do? Well, we want to create a new script. I'm going to call this arrow key control. And when I click create and add, we will get a new component called arrow key control. And you'll notice down here, we've got a new script. A new script has shown up in our project, okay? It is now in our file system. You could right click show and explore or show and finder, and you'll find it right there. And if we go in and double click on that component's name or on the file down there in our project pane, Visual Studio will open up. In Unreal, we wouldn't open Visual Studio. We would open up the blueprint editor, right? Let's go ahead and do that, actually. I'm going to go to this cube. I'm going to say, hey, I want a new component. New blueprint script component, please. Okay, actor component. I'm going to call this arrow key control. Okay. And then boom, okay, I'm editing code right now in Unreal. What do you see? Two lifecycle functions, event begin play and event tick. This one runs when the game starts, and then this one will run boom, 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 every frame as the game continues on. Okay? In Unity, we have the same thing, exact same thing. However, it looks a bit different, okay? This is C#. This is a textual programming language. It's one of the most popular in the world. I think it was number 5. So we got our component here. We have our two lifecycle functions. These are pretty much exact matches for what we had in Unreal, right? We've got start and we've got update. These functions will automatically be called in the same way that your main function is automatically called by the C++ runtime. We can use these functions to run our own logic at different times, okay? In Unreal, if you want to verify something, if you want to print a message, we do that via the, print string node. We can say like, hello world, okay? This will run once when the game starts. In Unity, we can do the same via the print function, okay? Or I actually prefer debug.log. Okay, and we can go hello world, okay? We've just done the same thing in both engines, right? That message will appear when we run our game. And let's go ahead and make sure that happens, right? Remember the iterative design process. You write a tiny bit of code, just a tiny bit, and then you test it to make sure it's doing what you think it's doing, okay? Break your tasks up into small little chunks, and development will be much more consistent. So we're going to run our game here, and we're going to look into this console window looking for a message to show up, and boom, hello world. It shows up right there. If you click on the message, you can even go down to this blue little hyperlink, and it'll take you to the exact line that caused the message. Okay? So very cool. Now, we need some way to move our object. But first, we need some way, actually, you know what? Yeah, let's focus on moving the object first, okay? So, we have, on this player game object, we have a few different components. We have a rigid body component that has this notion of velocity and gravity, right, and physics, right? If we want the ball to move, we somehow have to get a reference to this rigid body. But all the code that we are writing isn't in the rigid body component, it's in the arrow key control component right here. So somehow this arrow key control component needs to grab a reference to that rigid body so that we can do things to the rigid body, okay? So how are we going to do that? Well, Unity makes it super easy, okay? Super, super easy because you do this all the time actually, okay? So you can use a function, you're going to use this a ton, called getComponent. This getComponent function will ask you what kind of component do you want? And you specify that by using these little carets here, okay? Rigid body. Now, how many of you remember templates, function templates from EECS 280, EECS 281? This is the same thing, okay? So this function is going to get us that rigid body. When this function returns, it is literally returning a reference to a rigid body, and this is the rigid body it's returning, okay? It's going to find that rigid body for us. So actually, let's put it into a variable. Okay, rigid body, going to call it RB, okay? So now RB is inside, so RB is a variable that contains this rigid body right here. This means we can mess with it. So you'll do RB dot, and then thanks to our editor, Visual Studio, we got all of these awesome choices about what we could mess with. We got velocity, all right? We could mess with that if we want. But what I'm really looking for is some functions to like add a force, okay? And look at that. add force. This function doesn't return anything. It returns void, but it takes a vector 3, okay, a 3D vector, a 3D point, x, y, z, and that is the force, boom, that we're going to add onto this object, okay? So to test this out, what kind of force should we add? Well, what if we wanted to lift off into the air, like a rocket ship? What could we do? Well, let's go ahead and give it a new vector 3, right? A new 3D point. Do you remember which way is up in Unity? In Unreal, up is z, positive z. But in Unity, it's more like graph paper. So up is going to be positive y. Bingo. Good job. So we'll go x is 0, y is going to be, let's go like 10, and then z is 0. Let's find out what happens, okay? Every frame, we're going to apply this force to our sphere. But is this going to be big enough to lift us into the air? I don't know. We're going to find out. Let's watch. Play the game. Our component, oh my goodness. Okay, did you see that? It just went crazy into the air, okay? We'll run it one more time. There it goes. Boom. Okay, it just takes off into the air. Awesome, very good. So it's working the way we expect. Now the thing is, we don't really want to move up into the air. We want to move right or left, and we want to do that based on whether the player has pressed the right or left arrow key, okay? So how do we know if the player has pressed a certain button? Well, in Unreal Engine, it's really annoying, right? Very annoying. If you go into your VR pawn, okay, VR pawn, we have to use all of these little events right here, like event IA move, turn, okay, what else we got? We got grab left, grab right, okay. In Unity, it's actually much easier, okay. We can simply type input, then do dot get key, okay, get key. This function will return a Boolean to us. So it's saying yes or no, and then it takes a parameter of a certain key, a key code. So what this is going to do is it's going to give us true if the player is pressing that particular key code, and if they're not, it'll give us false, okay? So let's see. Key code dot, and then let's go right arrow, okay? This returns a Boolean, so in order to use that, we should put it in an if statement, okay? If the user is pressing a key and that key is right arrow, then we want to apply a force to the right. Now that's not going to be 0, 10, 0. It's going to be, how about 0, 2, or actually 2, 0, 0, okay? We can do the same thing, but for the left arrow, and instead of using 2, 0, 0, we'll use negative 2, 0, 0. And let's go ahead and test this. So we will return to Unity. It compiles the code, and let's see here. I'm going to press right now. Ready? 3, 2, 1, right, okay, and left, and right, and left, and nothing, okay? Hey, it's working, all right? Pretty simple stuff. And I'm guessing, let's take a quick poll. How many of you really ended up enjoying Blueprints by the end of it? Hey, that's awesome. Dang, that's like almost all of you, okay? What do you like about it? I'm curious. Yeah.
I think programming faster.
It made it faster and easier? Okay. I've definitely heard easier, but faster is a new one. I can see how it would be, though. Yeah.
It was like readable to people who didn't know this.
Okay, right. So if you are a bit less comfy with C# and textual programming, then it's going to be easier to read, possibly. Yeah?
There's no syntax errors.
Bingo. And that's a big one, right? If I'm typing here and I've already made this mistake and, you know, I mean to write left arrow, but I accidentally write let arrow, hey, that's a compile bug, okay? That's not going to compile. It's very annoying. And if you don't have code completion working, this is even worse, okay? With code completion, you can actually just start typing and then, you know, scroll down with the arrow keys, hit enter and grab the one you want, and that will guarantee no typo. But if you don't have that working, it's a big pain, okay? So I think what you'll find is that Blueprints make certain things a lot easier and maybe a bit faster, but if you need to do anything super complicated, if you want to have really interesting nested logic, or if you want to write any sort of mathematical expression, textual programming is king, okay? It is going to get you there much faster, and it's going to be much more pleasant for you, okay? How many of you have this code completion working, by the way? So how many of you can write D and it automatically brings up debug and then press dot and you got all these wonderful functions? How many of you have that working? Okay, if you don't have that, priority number 1 before you begin project 2 is to get that, okay? Whatever it takes, because without this, programming is just hellish, okay? Absolutely hellish. But with it, mwah, it is heaven. It is a simple fact that you're new to Unity and C#. You don't know what the functions are called. How are you supposed to figure out what functions are available to you? Well, you really gotta get this working so that you can see this menu of stuff, okay? Anyway, if you don't have that, office hours, let me know and we'll try and get that working for you, okay? Yeah.
Is that only compatible with Visual Studio?
So it is possible to get it working with Visual Studio Code, but it's kind of annoying and I've always struggled with that. With Visual Studio, like the normal version, it just comes right out of the box, which is very nice. Anyway, it is worth putting an hour or more into getting this working because it'll save you a ton of time and pain on P2, okay? All right, so we've got our character here and we can move right and we can move left. Now, you'll notice here that if I want to move faster or slower, I have to kind of change these 2s to something else, right? So maybe I'm thinking I'm moving too fast, so I change them down to 1. And now I'm going to move slower when I go back and forth. Now, this is a bit of a pain, isn't it? Right? It's really annoying. It's slow. I have to recompile. I have to test it. Now, what if my component had some interesting little variable I could tweak, right? You see these other components have all these variables, and you don't need to edit the source code for the component to change how it works. You just change the numbers that you see. You check a box, right? But arrow key control doesn't have that. Well, if you go into your code, right, if you ever write a public variable in your code, it will become editable in the inspector, all right? So let's say we want a variable. We don't want to have like 1 hard-coded in here. We want to have public float speed, okay? And I'm going to make that a 1. I'm going to plug this variable in so that we don't have to hard code our speed anymore. It's going to be right up there at the top of the page, a public reusable variable, okay? When we go back to Unity and we finish compiling, what we're going to see is that suddenly our component has that new speed variable, okay? And we can now change it. In fact, we can change it while we're playing the game, which is one of the coolest things about Unity, okay? Maybe you don't know what speed you want, but you can find out. So I'm playing around and I can see my player has a component called arrow key control and its speed variable is currently 1. Okay, and I'm kind of slow. But I can go and I can turn that not to 1 but to 10, and now watch this. Gonna just take off, right? Super fast, okay? All right. When I end the game, I lose all my changes. So if I want to keep that 10, I have to put it in here and fix it up after I'm done. But you can see this is how you make components that are easy to edit and really nice and useful, okay? You create variables, you use those variables, and then you can just edit them and tweak them from the Unity editor itself, all right? Super cool. So we can go right and we can go left, but I also want to go forward and backward. Which axis do we use to go forward and backward? You can use X, Y, or Z. You know, I have to create some new vector 3s, but I don't know which of these should be 0 and which should be speed, okay, or negative speed. What are we doing? I want to go forward and backward. If you don't know, you can kind of size things up. So that's my camera. And so I'm going to be kind of down here, and I want to go that way, kind of away from the camera. I can see the gizmo says that that axis is the Z axis, okay? And it goes X, Y, Z. So let's do that, all right? I'm going to copy this little chunk, okay? if we get the key and the player's holding the up arrow, then we want to go into the camera, into the screen. So X is going to be 0, Y is going to be 0, but our Z is going to be speed, okay? And kind of the opposite, if the user presses the down arrow, we're going to do negative speed on the Z-axis, okay? And let's go ahead. Let's test this out. I'm going to go ahead and play the game. And I press up, and I go away from the camera. I press down, and I come back toward the camera. I now have full movement in my game, okay? So it's starting to feel more like a player. But what about this? What if we wanted to create a larger world, okay? What if we wanted to make a larger world? We're going to pull this out a little bit, going to make this a little bit more thin, create kind of a walkway, okay? Maybe I can create another big platform. I'm going to duplicate that, copy and paste it, okay? Right? So I want to explore this world, okay? And I start moving over here, and I run into a bit of a problem, don't I? What's my issue?
You need to move the camera.
Yeah. So in Unreal, thus far, it's been a little bit weird for you because the camera is actually a part of your actor. It's a part of the VR pawn. In fact, if you look in the viewport for the VR pawn, you can see it. There it is, right? However, in Unity, it's different. In Unity, you've got your player game object, your player actor, and you've got a camera game object, a camera actor, and they're different actors, right? They're different game objects. So if we want to be able to see where our player is going when it rolls off to the left here, we need our camera to move over and follow that player as well, okay? And so we need to write some code on our camera game object to make that following action happen. Okay, now another poll real quick, because I'm just curious. How many of you are very experienced with Unity? You've taken 494, or you have taken the Game Engine Architecture course, or just used it in your spare time? Wolverine Soft Studio, maybe? Okay, so this is kind of probably a bit of a boring lecture for you. One of the interesting, tough things about not having a game dev program or a major is that if you go to Michigan State University, they have an entire program for game dev. Here we don't, right? So at MSU, everyone goes through some beginner courses, and after they do that, we know what people already know. So we don't have to cover things again. Here, we don't have that. So we've got some students who are coming into and using Unity for the first time ever, and others who have been using it for a while. And unfortunately, right, we have to go in and make sure that if you've never seen this engine before, you're well taken care of. So this might be a little bit of a boring lecture for you if you already know Unity well. However, please don't worry. Our next lecture is going to be much more technical, and you might have used Unity, but you've probably never used a map box before, right? Creating a Pokemon Go clone, getting an automatic map and GPS system running on your phone. I think that's going to be a little bit more interesting for you, hopefully. Okay? But anyway, we'll still make some things together, all right? So we've got our ball here, and this is a super useful component that we're going to make if you've never made this before. In a very general sense, we need this camera to follow some other game object. Or, to think about it in more general terms, we need one game object to follow another game object around with an offset, okay? So let's create a really generic component, right? We could create a component called my camera, okay? This would be a bad idea. Why? My camera. And we could put some logic in it that causes this camera to follow that game object. But we want to write code that is very kind of generic and reusable, right? And multi-purpose. So instead of writing something like my camera, let's write something like follow target, okay? And this component is going to have a few different variables. We want to be able to choose which thing we're following, right? So let's create a public game object target variable. And every frame, we want to move closer to it, okay? So we're going to move toward our target. Let's do this. Vector 3, desired position. The desired position for our camera is going to be the target dot transform dot position. Is this weird at all, this line of code to anyone? It is so common for developers to want a get component, and which component do I want? I want the transform component, right? You can see it right there. Every game object will have the transform component, and this is kind of a lot of code, so Unity did us a solid and just allows us to write dot transform instead, kind of a shorthand, okay? Then, right, we are going to move toward this desired position location. In fact, we're going to warp right onto it, actually, okay? We're going to move ourselves. So we're going to get our transform, okay? So we're going to get this transform, and then we're going to set its position variable to be our desired position. Okay? And we're done, right? Well, not quite. We created this public game object target variable, and there it is, right there. Except it's null. It's empty. This component doesn't know what the target it's supposed to be following is. So we have to tell it. We're going to drag that player right in there. And there we go. When I run this, our camera is now going to follow our ball, right? It's going to follow our player. Uh-oh, what happened? Did you see what happened? When I press left, I start to move left. When I press right, I start to move right. So what's the issue here? Yeah.
We're putting the camera at the position of the ball rather than the distance, right?
Bingo, bingo, okay? This is a pretty surprising result. However, it's obvious what the problem is when you pause the game. So remember, you can do that in Unity. If you're ever confused, you can pause the game, and then in the scene view, you can kind of look around and go, oh, my camera is literally inside of my player. And this makes sense, right? In our follow target logic, if you look at it, we simply grab the player's position and say, hey, that's where we want to go. And then we warp ourselves there. But we need to make this a bit more advanced, okay? We don't want to just move to the location of the thing that we're following. We want to do so with some sort of offset, okay? That offset should be customizable. So we'll go ahead and create a public variable, and we'll call this something like offset, okay? This offset is going to allow us to tweak our desired position. So now our desired position is the location of our target in addition to that offset, okay? So we can now set this offset to whatever we want. And if you think about it, right, we probably want to be a little bit negative on the z-axis. So let's go -5. And then on the y-axis, maybe we want to be a bit above the object. So let's go like a 3. And then on the x-axis, right, the red axis, we want to be aligned with the object. So let's try that and see how it looks. Right? There we go. That looks a lot better, but we're still a bit high, right? So we can edit it down. Let's go like that. Okay, how about 1.3 or maybe a 1.4, okay? 1.4 offset on the y-axis. Let's see how this looks now. And boom, right? It looks fantastic. And now we can actually explore our environment and kind of move around, and we can do stuff. All right? So this is kind of cool. But what if I want to make this game look a bit better? What can I do? Well, one thing you can easily do in Unity, right, as well as in Unreal, let's go ahead and let's find some grass, okay? Now, in 494, you get in trouble for doing this, right? You're not supposed to just go on Google image search and grab any image you can find. But that's exactly what we're going to do. So let's go ahead and do that, okay? I'm going to actually grab this. This grass looks pretty good. I'm going to call this grass, okay? Oh, that already exists. Yeah, well, let's replace it. Now, I'm going to grab that file. Let's go find that file. Okay, there it is. I'm just going to drag that file right into my editor. I got to drag it into the project pane. So we'll drag it right in. There's the grass, and I can just drag it right onto my objects, release, and now I've got some really nice grass, okay? There we go, okay? So this is already looking better, but you know, I'm not feeling the character that we currently have, okay? We've got this ball right here. It's a little bit boring, okay? So what are you thinking about? I'm thinking that this is kind of a grassy area. I'm thinking this is a swamp. I'm thinking that this should be a Shrek video game, okay? And so how are we going to go get Shrek into our game? Do you know anywhere we can search for awesome 3D models? We can search the asset store, but what I'm going to do is I'm actually going to go to a website called Sketchfab, okay? Has anyone heard of Sketchfab? This is an amazing website. I like it a lot. This is a website where artists, student artists, professional artists, hobbyists will just dump models that they've made, okay? And let's go ahead and search for a nice Shrek, okay? Look at all these options, okay? We got Shrek Wazowski. We got Dancing Shrek. We've got Cartoony Shrek's a human Shrek, right? We've got Minecraft Shrek. That's super cool. We need a downloadable Shrek. And unfortunately, downloading models is always kind of tough, right? You got to feel for that. You're trying to bring a model into your project. You're trying to get it working in Unreal. Often you have to tweak it. Sometimes it comes in, it doesn't look right. You have to hook some things up. Let's see if we can get this one working. Okay, this one looks pretty good. This one looks pretty good. So look around. Yep. And let's go to download 3D model. This is an OBJ. Yeah, OBJs don't usually work that well. So I'm looking for an FBX for Unity, okay? If you really want it, you can throw it into Blender and you can kind of edit it. Look at this. Yeah, let's try this one, okay? Let's try Shrek Wazowski. Okay, download. Here we got an FBX. Very good, okay? So we'll download that FBX. It comes in the form of a zip file. Got to open it up, see what's there. Okay, unzip that zip file. There's the folder, okay? We've got source, there's the FBX, and we got textures. What I always like to do, it's kind of annoying that they've been split up like this. We got our models down one folder path, we got our textures down one other folder path. I like to just grab them and put them together, okay? So we'll do that, and I'm gonna rename the source folder to just be Shrek model, okay? Now that we've got that folder ready to go, we can just bring it right in. I'm going to create a quick folder here, be organized, called characters. And then inside the characters folder, double click, I'm going to just drag in that Shrek model folder. Inside of it, we now have some images, yes. In fact, if I do this, it's going to look really hideous. Oh, look at that. Look at that. Oh, nasty. But we also have our FBX right here, and you can see that it actually imported pretty effectively. Sometimes this is messed up, and you have to go in, you have to click on materials and extract materials and then fix up the materials. But here, actually, it's looking really good, okay? So we've got Shrek Wazowski right here. Now, I want our Shrek character to be playable, so I'm going to go to our player. I'm going to tell it not to render the sphere. But what I am going to tell it to render is I'm going to bring in our Shrek right here. I'm going to just drag Shrek underneath the player. One big difference between Unreal and Unity is that in Unity, you can actually parent objects and actors to each other. And if you do this, what's going on here? Here we are. If you do this, when one parent object moves or rotates, all the children will get that same impact. So if we take the player game object and scale it, the child game object, Shrek, will also get bigger as well, okay? Anyway, I'm going to move Shrek around a little bit, get him nice and centered. That's looking pretty good. Maybe it could be a little bit better, okay? That looks pretty good. And now I don't want to render this sphere. So I'm going to turn off the mesh render, and now we just have Shrek, okay? Okay. Let's go ahead and let's play the game. See how it looks. Okay, and now I got my Shrek rolling around. All right, and we've got our little adventure with Shrek here, and we can get around. We can't do anything like jumping yet, which is something we might want to try. All right. However, we are over halfway through. So what I actually want to do is I want to take a 5 minutes, right? Let you use the restroom. I'll throw some music on. If you have any questions about any of this, you can ask it. We're going to come back and add a couple more features, okay? Try and get you used to the idea of working with Unity and what it is like. All right, so see you in 5.
Oh, is that like the
sometimes I talk about this. Oh, it's a response. Okay. So it's a that hard. If it's due Okay. So, we have gotten to the point where Shrek is in the game. Now, Shrek is not animating, okay? Shrek does not come with any animations. He is only a mesh, okay? A mesh, a bunch of geometry, a bunch of 3D points, edges, faces, and some materials to make those render in a cool way. If we want Shrek to be able to animate, what do we have to do? Well, we have to give him a skeleton, okay? Are any of you familiar with how animation tends to work? Right, at least humanoid animation. So you've got this massive collection of 3D points. And if you wanted to create the animation, you wanted Shrek to like wave, well, his arm has like 1,000 3D points in them, right? 1,000 vertices. You have to grab each vertex one by one and move it into the right place. It would be a huge pain. Every little change of the animation needs 1,000 points to be moved. Awful. So what most modern characters have is not just 3D points. That FBX will often typically have a skeleton. What is a skeleton? A skeleton is a really simple set of bones, okay? Some edges that go kind of throughout your character. And they can kind of split off and form a hierarchy. So you can start at the hip, you can go up to like the chest, and then one bone will go out this way, elbow, right, to the wrist, to each of the fingers, right? And what happens is all of the 3D points, the geometry that forms Shrek's arm or leg or head or neck, gets bound to the closest point on the skeleton. So that when the animator wants to move the arm, they don't have to grab each part of the arm, move that part, move that part, right? No, they grab the underlying skeleton and they just bend the skeleton like that. And all of the vertices that have bound that part of the skeleton will move just like so, okay? And that is how animation dramatically speeds up and has gotten much nicer over the years, okay? Skeletal animation. Now, the problem is we don't have a skeleton for Shrek here, and we don't have any animations for Shrek. But you know what we can do? There's a service called Mixamo, okay? This is an Adobe service, so we'd better use it and enjoy it while it's still here. What happens here is it's a service that allows us to basically create skeletal meshes automatically and assign animations to those skeletons. So if I want to upload a character, let's see if what we got here. Okay, let's see what we got. We got Shrek model. Yeah, I want to do that. Let's do this. Let's zip this back up. Okay. If you remember, inside of this folder is our Shrek FBX and its textures. It doesn't have a rig. It doesn't have a skeleton. However, what we should be able to do, or at least try, okay, we're going to upload that zip file. Okay, it's going to unpack. It's processing the character. Okay, just a moment. Hello. This is something I'm actually going to show you how to do because this is something you'll have to do on your P2, toward the end of P2. Did you do this for P1? Oh, you did? Oh, okay, so you already know this, right? Kinda. So you can see it has tried to create a skeleton and a basic animation. Now, it almost worked completely, but look at Shrek's poor ankles here. Ouch, okay? Not so great, but also not terrible. So now we can actually, now that we have a skeleton added into this, this mesh, we can now do various animations. We can click on them, and we can watch Shrek do them. Hopefully it looks okay. We can watch him dance. Okay, yeah, it's looking a little bit dicey. I want a nice run. Can we get a run? Okay. Oh, he's hurt and he's chasing you through the swamp. This is like the horror movie run. Okay. We got a ninja run. This looks really goofy. Very fun. Oh my gosh, we got an all-out run. This is terrifying. Okay, I want you to be in place. All right. And we can also adjust other things like the arms. I want the arms to go way out. Okay. Like an all-out run. Okay, so anyway, that is one thing that sometimes you'll do. You'll go find a model, you'll add it into your project, you'll decide, hey, I really wish I had animations, so you can then get Mixamo to generate the rig automatically, generate the skeleton, and then you can download those animations and put them in your project, okay? I'm not going to do that right now, because we don't really need that yet. But one thing I want is I want to jump here, okay? And fortunately, pretty much everything we currently know, we can use to make a jump, okay? So currently, when I press the right arrow key, we apply a force to Shrek. Now, what if I want to jump when I press the space bar? Okay? We can apply a force when the player presses space bar in which direction? Which axis? The up axis, which is the y axis. So x, y, z, we're going to need something like 0, 100, 0. Let's try that, okay? So let's go to Shrek. Let's go to our player, actually. Shrek is just the name of the model that is parented to our player. So our player, we're going to go to arrow key control. Down here, we're going to check if the player has pressed the space bar. And importantly, we're not going to use get key. We're going to use get key down. So get key is always true. The longer you press that right arrow key, the longer that true is going to come out. Now, we don't want that. We only want true to come out on the one frame that we press the space bar. If we hold the space bar, you're not going to keep jumping, okay? So that's what get key down does. You press the key down on this frame. And I want a particular key code. I want space bar. And I want to add a force. Okay, I want to add a force, but not on the z-axis, and certainly not downward, not negative, but on the y-axis. I don't want it to be speed either. I want to be able to customize what my jumping height is. So I'm going to go public float. How about jump power? What should it be? Let's try 100, okay? Why not? We'll try 100 first. We'll plug this variable in, and let's see what happens. Okay, I'm going to press spacebar, and we'll see if we lift off the ground. Okay, ready? So I'm running, and spacebar. Oh, it's not much, is it? Thankfully, it's a public variable, so we can pause the game, change this 100 jump power variable to 1,000, and now press space again. Okay, that's way too much. All right, let's try 500. Why not? Okay, that's a little bit better. I think 400 is going to be it. Okay, 400. It's probably what we want. Yeah, 400. That's great, okay? Look at what we just did, that iterative design process. We're experimenting, and Unity makes that super easy, okay? So what happens if I press spacebar while I'm already in the air? What's going to happen?
Double jump.
Double jump, okay? Boom. Yep, double jump. What happens if I press it a third time? Oh, I can just fly, can't I? Okay, so how are we going to deal with this? What are we going to do? Yeah.
Be like a variable has jumped and branch out.
Okay, right? So when I jump, I could have a variable. And it says, hey, you've jumped. You're in the air now, right? So you can't jump a second time. But wait, we want to jump when we return to the ground. So how do we detect when we got back on the ground? Well, in Unreal Engine, you have a way to detect when you've touched another object, right? It's the on-hit event or overlap, right? And those are events, and you can run some logic when that happens. That's how you did, right, the garbage can, right? You detect that the trash has touched the garbage can, you despawn that trash actor, okay? Let's create a variable, bool. Let's call this on ground. And we're going to assume that you start the game on the ground, okay? When you press the space bar, we're going to check, hey, are we on the ground? And if you are, we will add that force. Now, once we add the force, we're going to say, hey, you're no longer on the ground, okay? Probably. You're probably not on the ground anymore. Now, the hard thing here is, how do we change it back? We need some way to set on ground to true so that we can jump again. Otherwise, you've only got one jump, and that's the only jump you've got in the entire game, okay? So what do? Well, as it turns out, right, there are other lifecycle functions besides start and update. Now, one of those is going to be called on collision enter, okay? This is basically, let's see here, void on collision enter. There we are. So this is basically the equivalent of that hit, that event hit function. And it's also similar to Unreal Engine's event overlap, okay? So we got on collision enter here, and when we collide with something, what we're going to do is we're going to say, hey, on ground is equal to true. And because I really want to kind of test this, I'm also going to write a little debug message to the console, okay? I'm going to write a message, let's say, on ground now, okay? So let's go ahead and test this out. And because we have console messages we're expecting, I'm going to bring the console up and we'll look for those. Okay? Oh, we want to see the console, so I need to actually end the game. Let's make our screen smaller so that it stays kind of smaller when we play the game. Okay? So when we hit the ground, we're going to see on ground now. Boom. Okay, I'm going to clear that. I'm going to jump, and I'm going to try and do the double jump. Okay? Jump. Right? And on the ground. Jump. Right? Good. It's working. All right. We now have a pretty functional platformer. Okay? Now, the last thing I want to show you, in Unreal, that main big area that you were adding objects to, adding actors to, and customizing, that was called a map. Okay? And actually, you can have multiple maps. Did any of you write any code that actually switched between maps? Did you have multiple maps? Anyone? No? In Unreal, you don't really have to do it. In P1, it's not super important. However, on P2, you're going to have multiple scenes, okay? You're going to have the Pokemon Go, like walking around the city GPS scene, and then you're going to have a second scene that is much closer to the ground, where you're fighting the squirrels, you're planting the trees on the sidewalk, okay, stuff like that. And so, in Unity, they're called scenes. In Unreal, they're called maps. And if you think about what a scene is, all right, A scene is everything that you see. It is just a list of actors. That is all a scene is. Okay? Just a list of actors. And you could say, well, this is going to be called level 1. So let's save the scene, actually. I want to save the scene as level 1. But then maybe I want level 2. So let's save this scene as level 2, and we're going to edit it. Okay? We're going to have a different structure to our level. Okay? It's going to be like that. All right? And so how do we get from one to the other? Well, let's go back to level 1. We can find it right here. Scenes are just files, okay? I double-click level 1. We're back to level 1 scene. Level 2, we're to level 2 scene. Let's say that I want to have a cool object here that completes our level, okay? This is going to be like a collectible. It's going to be a nice little collectible here. There you go. Okay, it's a tiny little white box. Maybe it's magical. Who knows? Now, this box is going to have the name, let's call it goal, okay? Now, when Shrek bumps into goal, we want to go to that level 2 scene, okay? Let's go to player, let's go to arrow key control. We're already detecting if we touch the ground, okay? But we can actually say, hey, if the thing that I collided with, collision, let's see here, collision dot game object, okay, dot name, if the thing that I collided with has a name of goal, I want to do some special logic. I want to go to the next scene. So let's go scene manager dot load scene. Now, which scene do we want to load? What was it called again? It's called level 2. I want to load that level 2 scene, okay? Let's see if that works. Now, this is actually not going to work, I don't think. It's going to cause an error, but watch for the error, okay? So I'm going to roll over there. We're going to grab that goal, okay? And here it comes. And, oh, nothing happened. What's the problem here? Well, if you look in our console, we have this little red exception, okay? It's an error. And just like in Unreal, if you read it, it'll give you a hint as to what went wrong. It says scene level 2 couldn't be loaded because it has not been added to the build settings, okay? So go to File and Build Settings to add it. So we're going to do that. File, Build Settings, I can add my open scene. We just added level 1, but what I want to do is I want to add level 2. So I'm going to drag it up there. Now level 2 is in our build. Hopefully we can go ahead and run it. So here we go. Hopefully we don't see that error message again. Here we go. Nice big screen playing the game. And, oh, there we go. Right? So we can now switch between scenes using a single line of code. It's not that hard. Scene manager.load scene. And then provide the name of the scene you want to load. Okay? If this part confused you, right? Whenever you collide with something, this function is going to run. But sometimes you want more information about the thing that you collided with. And that information, Unity will pass it to you so that you can use it. Unity gives you this information in the form of this nice collision object that gets passed in. You can write collision dot, and you can see all the nice information that Unity is providing to you. Okay? You can get the contact point, so the exact point that you collided at. You can get the relative velocity in here as well. And you can get the actual game object that you touched. Okay? So that allows you to customize and make your logic more sophisticated so you can respond to the collision in a unique way. Okay? All right. So, right? This is Unity. And pretty much everything that I've taught you about Unity in this little, quick lecture, it's something that you've already done in Unreal, right? Now, maybe you didn't switch between maps in Unreal, but you better believe there was a node for that, okay? And, right, do you remember doing some collision work, some collision logic in Unreal, okay? You remember getting some player controls to work in Unreal. And so basically everything that you've done in Unreal has an equivalent in Unity. And in fact, in many cases, it's easier in Unity to do the thing, okay? Unreal has so much going on and so many features that it can be blinding. It can be hard to find the thing that you need. However, in Unity, right, these things are often much easier to find. In particular, if you want to add some more complicated logic in Unreal, that will become a visual spaghetti, right? In Unity, often it's actually, I think, a bit easier to read, okay? You will get used to it. Eventually, you'll be reading this code very quickly. You'll feel more comfy debugging and experimenting in C#. And I think you're going to enjoy it, okay? This is a wonderful, wonderful engine. There's a reason Unity is usually called the beginner engine, okay? People like jumping into it. It's very friendly in many ways. As long as you know how to program, C# is a really great language. I think it'll come to you quickly, okay? So, on Monday, we're going to come back. We're going to launch your next project. P2 is often said to be the harder project of the two, okay? But it is also often said that it's the more satisfying project, okay? This is going to be a project, right? You're going to have Pokemon Go that you made on your phone. And that means you're going to be able to show it to friends, right? You can take it, you can show it to family, right? You can play the game a bit if you want to. With VR, as cool as VR is, you're often stuck, right? You're tethered, anchored to a certain location, right? Getting friends and family to come here, not always easy, right? They're on Central Campus or something. They don't want to come up here by bus. So hopefully you'll have a good time on P2. You'll learn a lot. If you're already used to Unity, you're familiar with Unity, you will be delving into a very complicated new technology in Mapbox, a very powerful new technology. So I hope you'll enjoy that. And yeah, we'll be exploring the world of AR. So I hope you enjoy it, okay? If you have any questions about any of this, let me know, all right? Again, you don't need to memorize or study any of this, but hopefully your confidence with Unity is starting to go up, right? You can get this done. You can figure this out, okay? And I'll be around for the next hour or so until 4:30, and then I'm out to go to IGDA Ann Arbor. Remember the Roblox event tonight? If you're into that, be sure to be there, or IGDA Ann Arbor if you want a tiny bit of extra credit. To be honest, in this course, you usually don't need it, okay? Yeah, I'll throw some music on. Thank you for joining us, okay? It's good to see you. All right, everyone online on Twitch, good to see you as well. Take care. Bye-bye.